Hello, Bridge. How are you doing? It's week 7. It's the second assignment, and we're still going to meet. We're just taking it slow as our introduction into quadratics. We're going to be looking at the shape of quadratics today and just making sure that feels really good before moving on to some more technical mathy stuff. I mean, it's all math, but anyway. Bridge of the day, does it possibly look familiar from a movie? It is the Millennium Bridge in London. And actually, it's, of course, Dementors are not real, but like the Dementors in Harry Potter or something Harry Potter, I can't remember. I think that little scene was filmed on that bridge. Maybe it was the Death Eaters. I honestly can't remember. Haven't seen that movie in a while. Today, again, we're looking at the shape of parabolas and quadratics. I'm going to switch over to Desmos here in just a second, but I want to talk about like the most basic shape. Again, we've talked about this last, like our basic parabola, y equals x squared. The graph of that thing looks something like that, all right? So we're going to see as we add in numbers or as we change things in this function, how does this graph also change, all right? So I'm going to switch it over to Desmos. What I have graphed here in red is the basic function y equals x squared. And if you see on the left-hand side of the screen, I'm turning it on and off. I'm going to be going through all of these little functions, and we're going to talk about how this graph is changing. So my next one, y equals x squared plus 4, it's the one right under the equation that I have graphed. Let's just make a guess of what's going to happen when I add 4 to this function here. So if I add 4, I'm adding 4 to the end of the function, right? So everything should get bigger by 4. Basically what I'm saying is that all of the points on this quadratic is going to be shifted up 4 units. So let's see if I turn this thing on. Yep, my quadratic, it looks like everything just moved up 4 units. You see in the original red one, my vertex is at 0, 0. And now that it's been shifted up 4, my vertex is at 0, 4. All right? So everything just went up 4 units. We would even call this a vertical shift. So this was technically a vertical shift up 4 units. Okay. Let's look at what happens when I put something on the inside. So when I added 4, it went up, and that was adding 4 after I have squared x. But what if I add 1 to x before I square it? And you see in the next function, that's what I have. I have x plus 1 quantity squared. So when I put a plus 1 on the inside there, I'm going to turn that on. Hey, check it out. Now this thing just shifted over to the right. I'm sorry, to the left. Man, I don't even know my directions. So this thing just shifted over to the left, all right? So it's just what we call a horizontal shift. So changing a number or adding a number into the inside of the parentheses there before I square whatever the x value may be is going to result in a horizontal shift. What about this next one here? All right? I keep changing this thing. Okay. The next one says y equals negative x squared. So negative x squared, all right, you plug in an input value to see what it's going to get. You square it, and then you have to make it negative. So that's going to make all of your output values now negative. Notice how in this original function, y equals x squared, all of my y values, this function is all positive. It's all above the x-axis, all right? But when I make it negative, my function should flip down so that all of my y values are negative, so that my entire function is below the x-axis. So let's see if that happens. Yes, indeed. I turned on y equals negative x squared, and I see that my function is basically what happened is it just flipped over, right? It was reflected across the x-axis, all right? So if you put in like a negative in front of your function, it's going to do a reflection, all right? It's going to make everything negative. So the next one is 2 times 2x, and what this one is going to do, it's essentially going to stretch my function out. So, like if you think about before when we had our x squared plus 4, that was a vertical stretch, and we just shifted all of our points up 4. Now, when we multiply by 2, we're just multiplying all of our points by 2. So everything's going to get kind of stretched out. All right? So, I keep moving it that way. Okay. So if you look, my vertex is still at 0, 0, because if I multiply an x, if I multiply 0 by 2, it's still just 0, right? So my vertex is the same. But what if we look at the point 1, 1 in our original function, right? I can't get it quite just, there it is, 1, 1 in our original function. If I take that and multiply it by 2, it should now be at 1, 2, which, at 1, 2 now. So I just multiplied everything by 2. If I take another point, for example, let's do 2, 4. I know that if you take 2 and you square it, you're going to get 4. But if you square 2, you get 4. Then I also have to multiply by 2, so that I should have another point on my new function here at 2, 8. Just notice how everything just kind of got stretched out a little bit, all right? So that's essentially what we're doing, all right? There's just a whole bunch of transformations. You can make a ton of different parabolas with this. What if I wanted to say x squared plus 3 or plus 8, right? Then that would shift it up 8 units. If I said minus 5, then that should take my original red one, right? It's going to take it and it's going to shift it down 5, all right? Or if I said, you could play around with this a whole bunch. What about plus 5? Oh, I got to turn it on. There it goes. There it goes. So plus 5, right? It shifted it over 5 units. Or maybe you want to do, instead of 2 times x squared, which is like a really nice stretch, maybe you did 3 times x squared. As I increase that number, look how it's getting skinnier and skinnier. It's being stretched even more. Oops. And more. If I did 20, look at how thin that is, right? What if I made that a negative 20x squared? Well, as soon as I put in a negative, it flipped down. It flipped across the x-axis. All right. So basically, that was just some fun introduction stuff to making some different parabolas and quadratics. Back to this, I'm going to explain the homework real quick. There are 2 options that you can do. For option number 1, I would really like you to do option number 1 because I think it's really actually fun and it's cool. If you go to student.desmos.com, I know we've done some of these before. Go to that website, use the class code WBU5Y9. All of the letters are capitalized, and it's going to ask you to go through some slides, and if you stay tuned in the end of the video, I will also show you, I'll kind of walk you through it. I think it's really fun. It's a cool activity. I enjoyed doing it. And then option 2, maybe your internet's not working very well or whatever. There's some multiple choice questions, sketching some graphs, identifying some transformations, all right? But I would really encourage you to do option number 1. It's pretty cool, all right? So go check that out. And again, if you're doing it in student.desmos and you please put in your real name first and last so I can actually see your progress, because I can go into the teacher side of it and I can see how many questions you've gotten through, all right? So wonderful. Have a great day, and I will see you later. Adios. Hello, Bridge. This is a little preview of what the homework is going to look like. I'm going to keep track of your progress if you're doing the homework. I'm going to keep track of your progress through here. You're going to join the class, and I will be able to see how many problems that you complete. So it's will it hit the hoop, which is a pretty cool thing, and we're still getting our introduction to quadratics. Who knows how long our unit's going to last, because I think we only got a couple more weeks. You guys are doing great, though. Anyway, so you're going to go to student.desmos.com. You're going to join the class that I have set up, the class code, and I will type this in somewhere as well. The class code is WBU5Y9. And then enter in your nickname. Please put in your first and last would be great, so then I can, again, see who you are. And then you can hit go. And I'm just going to walk through the first few, all right? So it says drag the black points. So here we have a nice line, and we have a whole bunch of points. Ooh, let me zoom in, perfect. It has a whole bunch of points, and we can try and model these sets of data using a linear line by dragging those points and creating a line of best fit. That is essentially what we're going to do, but with quadratics. So I've made a line that kind of fits those data points, and then I can say, uh-oh, if I wanted to model the path of a basketball as it's being shot into the hoop, I probably shouldn't use a line because this is not a linear path. Again, we're working with quadratics. This is probably going to be a quadratic path. So why does your line, or what does your line say will happen to the basketball if you model it off of these first 5 dots? Stop. If you model off after those first 5 dots, do you think you're going to get an accurate path of the ball? Just answer the question. Give me a little blurb in the little box here. And I'm going to hit next again. So yes, we're looking at quadratics. Go ahead and read this. I'm just doing it quick so you know exactly what these buttons do exactly, all right? All right. These first, it's got, this guy is outside of a school and he's shooting the basketball and he shoots it about 7 times, all right? So you're going to watch each shot and make a prediction. Do you think that that is going to go in or out? All right, so you can follow with your eyes if you want to get a pencil and kind of follow it on the screen. I'm just going to take a guess and say it's going to go out. I don't think that's going to make it in, all right? So I hit out and then I hit submit because it's going to save it for later, and then you can hit next, all right? Again, watch these shots, take a guess. I'm going to say that one goes in, so I'm going to hit in and hit submit, all right? So there's like 6 different videos of him making these shots. Take a guess. They're like 3-second videos. Once you get through all of them, then it's going to actually go back and have you analyze each shot. So with this first shot, let's see if we can find a quadratic that matches this path of the ball. So I'm going to kind of try and line up this curve and see if I can get it pretty close. I think that looks pretty good. All right, so those dots are just about all on that line, and if I follow that line through, yeah, it looks like it's probably going to make it into the basket. So it says previously I predicted the ball will go out. You know what? I'm going to say it's going to go in, and I'm going to hit submit. Okay, so I was able to take a curve, line it up with that path of the ball, and make a more accurate guess instead of just eyeballing it. All right, so again, what I want you to do is take these curves here and line it up with the ball and make a guess if the ball will go in or out. Please, again, put in your name into the class, all right? And then I can see your progress, all right? Using that special class code that I've made for Bridge, I will be able to see who has actually logged in. And if you're worried about, getting the assignment in, just send me an email or send me a screenshot and say, hey, I went through the first, 20 or something. All right, sound good? Let's say I'm gonna ask for at least the first 25 slides. All right, at least the first 25 slides. I think that sounds good. You can do the rest of them as a challenge if you want, but get through the first 25 where we're playing around with these quadratics and parabolas. Thank you so much, you guys. Have a great day. Bye.